to the channel Amazing Civil Engineering Studies. In today's video we are going to discuss about temporary adjustment and methods of plane table surveying. In this method we do following things: fixing, centering, leveling, orientation. Fixing is the process in which the plane table is properly fixed on the tripod stand. White drawing sheet is then placed on the flat table and properly fixed with clips or thumb screws. During the whole process of plane table surveying, care should be taken that the position of the drawing sheet should not be misplaced. Centering is the process in which the plane table is properly centered by using a plumbing fork, which is very similar to plumb bob. It is used to mark the center point on the ground, which exactly represents the center point on the drawing sheet. Leveling is the process in which the plane table is properly leveled by using spirit level. The plane table should be parallel to the ground surface. The survey should not be carried out until the table is properly leveled. Orientation is the process of setting the plane table into some fixed direction so that the line representing a certain direction on the plan is parallel to that direction on the ground. In the plane table surveying, the whole table needs to be moved at several stations to complete a survey. Every time the table is moved, one has to make sure that the new station is parallel to the previous one, otherwise the lines drawn on paper will not represent the same lines on the field. Methods of orientation are: orientation by magnetic needle, orientation by back-sighting. Different methods of plane table surveying. Radiation method. In this method the instrument is set up at a station and rays are drawn to various stations which are to be plotted. The distances are cut to a suitable scale after actual measurements. This method is suitable only when the area to be surveyed is small and all the stations are visible and accessible from the instrument station. The scope of the method is increased when the distances are measured by a tachometer. In the field it is sometimes used to locate the details of the area in conjunction with the method of traversing. It is the simplest method of plane table surveying. This method is only effective if the whole surveying is to be done from one single station, i.e. the table will be in such a position from where all the other points of the field are easily visible. The procedure is as follows. Point P is to be selected in such a fashion that all the other points, A, B, C, D, E, are seen easily from P. Center and level the plane table over P. Mark the direction of the north on the sheet by using compass. Locate instrument station P on the sheet by using plumbing fork, such that P on sheet is exactly over PON ground. Centering the alidade on point P, cite various details step by step and draw a ray from each detail along the fiducial edge of the alidade. Let the details be named as A, B, C, D, E. Now measure the distances of each point from Pi.E. PA, PB, PC, PD, PE, and plot them to scale on the sheet as PA, PB, PC, PD, PE respectively. Joint A, B, C, D, and ETO give the outline of the details. Note, these details may be building corners, electric towers, tree, manhole, etc. But for demonstration purpose we will put ranging rods. Intersection method. In this method 2 instrument stations are used but no chain or tape is required. Intersecting rays are drawn from these 2 stations whose location is already plotted. By measuring the distance between them, the point of intersection is the location of the point. In this method 2 stations are so selected that all the other stations to be plotted are visible from these. The line joining these 2 stations is called base line. The length of this line is measured very accurately. This method is very commonly used for plotting details. It is referred when the distance between the stations is too large or the stations are inaccessible or the ground is undulating. The most suitable example is of broken boundaries which can be very conveniently plotted by this method. Procedure. Select 2 instrument stations P and Q, such that all the points or details to be located are visible from both the stations. Now set the table on P and make it centered and level. Using the plumbing form, locate the ground station on the sheet IEP, such that the point P on the sheet is exactly over the point PO and the ground. Measure the distance between P and Q. Now using the alidade pivoted at porient the table so that other instrument station cheese-sided and clamp the table and draw a line along the fiducial edge of the alidade according to a suitable scale. This line PQ is a base line and hence must be measured and drawn accurately. With the alidade pivoted on P, cite other details and draw rays as A, B, C, D, etc. as shown in figure. Now shift the table to station C and make it centered and leveled such that point Q on sheet is exactly above the C on the ground. With the alidade placed along line PQ, orient the table and back cite the station P and clamp the table. With the alidade pivoted on Q, cite other details and draw rays as A, B, C, D, etc. as shown in figure. The intersection of A, B, C, D, E with A, B, C, D, E are named as A, B, C, D, E, respectively. Join A, B, C, D, E as shown in figure. Note: these details may be building corners, electric towers, tree, manhole, etc. But for demonstration purpose we will put ranging rods. Traversing method. This method of plane table surveying is used to plot a traverse in cases stations have not been previously plotted by some other methods. In this method, traverse stations are first selected. The stations are plotted by method of radiation by taking back sight on the preceding station and a foresight to the following station. Here distances are generally measured by tachymetric method and surveying work has to be performed with great care. Let us consider the stations P, Q RANS which are to plotted by method of traversing. Stations are to be chosen in such a way that adjoining stations are visible. First, the plane table is to be set at station P and then plotted as P. The orientation of the table and scale of plotting should be such that all other stations will be accommodated within the boundary of the sheet. With the alidade pivoted at P, draw the rays to cand S. Distances PQ and PS are measured and plotted on the respective rays, PQ and PS respectively. The plane table is then shifted to station Q, get it set and then oriented by back sighting to station P. With the alidade pivoted at Q, draw area E to R. Distance QR is measured and plotted on the ray as QR. In this way, plane table is shifted to stations RANS and corresponding rays are drawn to obtain the plotting of the traverse PQRS. Check lines. To check the accuracy of the plane table traverse, a few check lines are taken by sighting back to some preceding station. In this example, a check line RP is drawn from the station RTOP when the plane table is occupying the station R. If the traverse is correct, the check line RP would pass through P, the plotted position of station P. Likewise, a check line SQ is drawn from STO Q. In case there is no suitable preceding station visible, any well-defined point, such as a corner of a building or a tree, which has been previously plotted, can be used for checking. Likewise, a check line SQ is drawn from STO Q. In case there is no suitable preceding station visible, any well-defined point, such as a corner of a building or a tree, which has been previously plotted, can be used for checking. Error of closure. If the traverse to be plotted is a closed traverse, the foresight from the terminating station should pass through the first station. Otherwise, the amount by which plotted position of the first station on the foresight fails to close is designated as the error of closure. It is adjusted graphically, if the error is within permissible limits, before any further plotting works are done. Resection. In this method, the location of the station occupied by the plane table is obtained by means of drawing rays from the stations whose locations have already been plotted on the paper. Resection may be done with the help of 2 points or 3 points. Procedure. Select a baseline PQ on ground, measure it accurately with steel tape. Set up table at P, center it, placing alidade at line PQ. Orient table by running ray until sighted, clamped it. With alidade touching P, sight R, which is to be located by resection. Shift the instrument and set up at R. Orient the table by taking back sight on P. Clamp it. With alidade centered at Q, sight the station can draw a ray. The point of intersection of this ray and that previously drawn from P gives the required point R. This method is called back ray method. 2-point problem. 2-point problem consist in locating the position on the plan of the station occupied by the plane table, by means of observation to two well-defined points, which are visible from the instrument station and whose position have been already plotted on the plan. 3-point problem. In this method, three well-defined points, having locations already being plotted on the drawing, are involved. These are used to find and subsequently plot the location of the plane table station. The method is based on the fact that, in a correctly oriented plane table, resectors through well-defined points get intersected at a point which represents the location of the plane table station on the drawing. For example, as shown in figure, if X, Y and Z are well-defined objects present in the field whose plotted positions are X, Y and Z. Now, if the plane table is oriented correctly, the three resectors XX, YY, and ZZ get intersected at P, which represents the location of the plane table station, PO, and the drawing sheet. Thus, through solution of 3-point problem, both orientation and resection of plane table gets accomplished simultaneously. There are several methods for solution of the 3-point problem. I. Trial and error method. 2. Mechanical method. 3. Graphical method. 4. Analytical method. And V. Geometrical construction method. Of these, the trial and error method is easy, quick, and accurate. It is commonly used in practice and hence, has been discussed in detail. Trial and error method of solution of 3-point problem. In 3-point problem, if the orientation of the plane table is not proper, the intersection of the resectors through the 3 points will not meet at a point but will form a triangle, known as triangle of error. The size of the triangle of error depends upon the amount of angular error in the orientation. The trial and error method of 3-point problem, also known as Leemans method, minimizes the triangle of error to a point iteratively. The iterative operation consists of drawing of resectors from known points through their plotted position and the adjustment of orientation of the plane table. The estimation of location of the plane table depends on its position relative to the well-defined points considered for this purpose. Depending on their relative positions, 3 cases may arise. The position of plane table is inside the Great Triangle. The position of plane table is outside the Great Triangle. The position of plane table lies on or near the circumference of the Great Circle. In case of 3, the solution of the 3-point problem becomes indeterminate or unstable. But for the cases I and II, Leemans rules are used to estimate the location of plane table. Leemans rules. If the position of plane table station is inside the Great Triangle, its plotted position should be chosen inside the triangle of error. If the position of plane table station is outside the Great Triangle, its plotted position should be chosen outside the triangle of error. The plotted position of the plane table should be so chosen that its distance from the resectors is proportional to the distance of plane table station from the field positions of the considered objects. The plotted position of the plane table should be so chosen that it is to the same side of all the three rays. 4a. If the position of plane table station is outside the great circle, its plotted position should be so chosen that it lies on the same side of ray to the most distant point as the intersection K of the other two rays. The intersection of two rays to the nearer points is midway between the plotted position of the station and the ray to the most distant point. 4b. If the position of plane table station is outside the Great Triangle but inside the Great Circle, the plotted position of the station is so chosen that the ray to the middle point lies between plotted station position and the intersection of the rays to the two extreme points. Steps for solution of 3-point problem. Let x, y, and z represent the ground location of the well-defined objects whose plotted positions are x, y, and z, respectively. Let P be the plane table station whose plotted position, say P, is to be determined. Select a plane table position inside the Great Triangle XYZ and set up the table over pand oriented by judgment so that a parent line XY is approximately parallel to the imaginary side XY. Pivoting the alidade on X, Y, and Z, bisect the signals placed at X, Y, and Z, turn and draw rays. If the orientation of the table is correct, the three rays will meet at one point, which is the desired location of P on the sheet. If not, the rays will form a triangle of error. Choose a point P inside the triangle of error such that its perpendicular distances from each ray is in proportion to the respective distances of P from the three ground objects. For selection of location of P, Leemans rules 1 and 3 need to be applied. Align the alidade along Px, assuming STO be the farthest station, rotate the table till flag at Z is bisected, and clamp the table. V. Pivoting the alidade on X, Y, and Z. Repeat the process as in step 2, above. If the estimation of P as P is correct, the three rays will intersect at a point, otherwise again a triangle of error will be formed but of smaller size and within the previous triangle of error. Estimate again the location of P in the new triangle of error applying the rules I and 3 and repeat the steps 4 and V. The method is repeated till all the three rays intersect at a point. The point of intersection is the required location POF, the plane table station P. Note: the points to be kept in mind while surveying with plane table. The small letters A, B, C are used to represent the stations on the paper. The table will remain stationary while the alidade is rotated to cite the station. While taking the reading, the alidade must be centered. The board is turned only when the table is to be oriented. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.